Hi, today we're going to calibrate the front radar on this 2017 Volkswagen Golf. It had an issue with a little bit of damage on the front grille in the area of the mounting point where the front radar clips in. So some of these little plastic clips were a little bit damaged and the radar was after kind of popping out of position, so it wasn't sitting in right in the grille. This model Golf we'll show you in a moment. It has the radar in behind the badge, where the older ones had it down in the lower part of the bumper. So yeah, it was after coming out of its mounting point, and then the symptoms or the complaints the customer had was when they were driving, it was coming up on the display saying something like front assist, no sensor view or no sensor available. And when we done a diagnostic check, it also had a fault code C110B, sensor for automatic distance control, limited visibility. So on looking at it, and these are such a safety sensitive thing, we just replaced the grille, and now after replacing the grille, the radar will have to be calibrated. So we're going to use this Sice PROADAS system to calibrate it. We use this in our own workshop, and we also supply and support and provide training on these ADAS calibration systems. We've done some other videos on this, and Sice also have some good videos showing some general information on it. I'll put links in the description in this video to the other videos about it. So for any calibration on ADAS systems, it's necessary to carry out various pre-checks to make sure the car is in good order. So you'd want to always check the steering and suspension system for play or worn joints, check tyre pressures, check that there's no load or weight in the boot or anything inside in the car, and there's various other checks. In the software it'll guide you through all the manufacturer's recommended checks, but like there is some various generic checks you should always perform as well. We won't go through all of them, but you'll mostly be guided completely by the software on what checks to perform. So then we'll start up. So we have our tablet here then. The Sice PROADAS system uses the Technomotor diagnostic software in connection with it, because they're all part of the one company, the Nexon group. So we're just going to go into ADAS, Volkswagen 2017. So we're the Golf 5G model year. She's the 17 model. So now we go in here and we're going to go front radar. That's the system, Bosch VW416. So we're going in here, and then we have different options here. Just if you want to just do general diagnostics on it, want to code in a new front radar, or we want to do the static calibration. So we want static calibration. Now it's asking us, do we want to scan the vehicle errors? It's always a good idea to check for faults in all kind of related systems before we proceed. And I'll just turn on the key. So we have our Technomotor Socio X3 interface connected to the car here. We'll open Bluetooth. So go ahead and scan the errors. So we can move around with this wherever we like. I just have it sitting here for handiness sake. So now it's going to scan these control units. It's only scanning control units that it's kind of the radar is directly linked with. We can go out and into the full diagnostics and do a full scan on all control units, but in this case, that's the way they have it set up, just to scan systems that are kind of safely related and related to the operation of the radar. So that's kind of it. So I just key in the registration. So we'll go OK. So all these are clear, we have no faults in them. ABS green tick, all the ones with green ticks have no fault codes in them. And question marks, I think this vehicle doesn't have these systems fitted. So if we wanted to, then we could go into individual control units to do various checks in there if we did have a fault code in there. In this case, it's probably no harm to go in here and check our steering angle sensor to make sure the steering angle sensor is calibrated correctly. This will be one of the pre-checks as well when we go in later on in the software. So we're in and connected here now. We have our data stream up here, so I'm just going to scroll through it just to find steering angle. Steering angle sensor, yeah. So we'll just go over to the car here. We had follow me over. So we have our steering wheel lock on. Yeah, so we're just going to center our steering wheel. So I just have the steering lock and clamp on as well. So I'm going to lock it to the straight ahead position and see, are we getting straight ahead on the steering angle sensor also. Yeah, that's close enough, yeah. So it's steering straight ahead and we're near enough to zero on the steering angle sensor. So we'll just go back to the So now we can go back over here once we know that the steering angle sensor is calibrated correctly and in near the zero position. So now we'll go back into front radar again. And there we go, calibration again. And now it's going to skip the diagnostic part because it knows we're after performing that part of the test already. We could have chosen not to go in and do the scan of them control units, but it's better, I think it's better to do it all in one process. So now it brings up some of the instructions here, your procedures. So it's saying when it has to be performed. So if the radar has been replaced, has been removed or refitted, support has been replaced, which in this case is the grille, the front sensor beam causes an error, so if it's logging a fault code, if the rear toe is adjusted, so basically if the toe or the thrust angle of the car is after changing, it has to be calibrated, or if any repairs are being carried out to the front area of the car, or any variation in height. So again, you can read through all these. The more you do, the more used to get. It'll just come second nature, so you don't have to spend all the time checking every single detail on it. But in the first few times, it's better to read through everything thoroughly. So it's just saying flat level surface. You can also use this on a lift, but if you're going to use it on a lift, you have to go into the settings menu and put in the thickness of the lift platform. So all these other warnings then, surface must be clean, where the radar is mounted, engine off, nobody inside, and so on. Boot empty. Battery support unit connected, which we'll put on, and we'll connect it up in a few minutes. So there's just some other warnings, so we'll just go on to the next place. Now it's asking us, do we want to perform an alignment pre-check? So with this package, we have the alignment pre-check option on it, and this system comes with the 4 CCD heads, wheel alignment heads, that's used with Sice's and other Nexon Group companies' alignment system like Corgi and HPA. and so on, and all their other brands. So it's the same heads as is used with them. So we'll go on to the next step. So it's telling us what we need. We need 4 clamps, measuring heads, steering lock, which we already have locked. Vehicle preparation, steering clamp on, wheel lock straight ahead. Install the 4 brackets. We have them all on bar 1. We'll put the other one on there now in a moment. And for installing the heads. So we'll put on the last bracket here. Brackets, these are the brackets that come with it. There's also other quick clamps available as an option, but these are nice light brackets. They have a mechanism here for setting an offset if needed for vehicles with low bumpers or spoilers. But it's a nice light bracket with good quality connection points and very positive connection points on it. So we'll go on with the last bracket. Even with this wheel, with a very low profile tyre, there's no issues. So I just give it a tap in all around. Yeah, that's the last bracket fitted. We have the other 3 already on just to save time. So then we'll get the sensor heads. Front right. Just going to switch them on here now when I'm here as well. And level it. Right. For the start of the ROC procedure, which we'll have to do in a few moments, the heads have to be level at the starting point. All the heads level, so we're going to hit the ROC. This run-out compensation, it allows for slight deviations in the way the clamps are fitted. They're not fitted exactly correct, or allows for a little bit of a misalignment. So it's the same as on any standard electronic wheel alignment system. They all have this run-out compensation. Can skip it or recall it, but you're better to do it. It makes it more accurate. So click ROC. So we'll keep the vehicle in the standstill position while it takes its first measurement automatically. You're hearing the heads beeping. So now it's telling us to move the vehicle backwards by 90 degrees. So I'll push the car back for 90 degrees. Watch any of the wheel clamps and just go by 90 degrees. Once you're back, then you can press any of this button on any of the heads. Again, then you just have to wait. Just move your foot there so we can block the beam of the heads. So now it's after going on to the next step. Move the vehicle back to starting position. position, then just press the yellow button on one of the heads again. Any of the heads, any one head. You just have to wait then for a few seconds. So ROC procedure result is okay. So now we need to level the heads, because the next step is going on to the alignment. Level and lock the heads. Now we have the 4 heads levelled. Except that one, sorry. Which one is it? Back left. And we can proceed on to the next step. So now it's asking us for specs of the vehicle, or the vehicle details, because it's bringing up the wheel alignment database. So ours is the JTD 17 to 20, okay. It's asking us to input the wheel size. 19 inch. Okay. So now this is like a wheel alignment pre-check. Again, it just takes a couple of seconds for it to pick up the heads. Maybe your feet just. Yeah. So now it's after bringing up all our readings. This is our pre-check on the wheel alignment. So we have our total toe on the front of 1.3 mil. Our toe on the front left is 0.5, front right is 0.8. So we have our half toes on our total toe. We have our camber, left and right. Then on our rear, same thing. We have our half toes, total toe, cambers, and most important one then in relation to when we're calibrating cameras or radars is our thrust angle. So that's all good. Alignment is good. So that's if we're happy enough with the alignment. If the alignment had been off, then it would have prompted us, did we want to proceed or stop and correct the alignment? It will allow us to proceed, but then the report at the end that it's going to print off will show that the alignment was incorrect. So really it'll let you go on, but it doesn't want you to go on until you correct the alignment. So now we can go on to the next step. So it's bringing up a list of things that we need now to calibrate the radar. So we need the trolley, the calibration or the radar glass that's already mounted on it here. The radar screen, whatever you call it. Two wheel heads we have them already on the back of the car, so we'll be leaving them 2 on the back of the car. We'll be using the 4 heads, so we'll have 2 on the back of the car and 2 on the structure, our diagnostic interface, our distance meter, and our inclinometer. So we'll go on to the next step, positioning the vehicle. So it's telling us upon our steering wheel lock, about setting up the structure, figuring out where the radar is mounted. In this case, it's in the badge, behind the badge. In some of the older Volkswagens, it was down here. When we're squaring up the frame to this and getting the distance from the car, we're doing it with this distance meter. which will be transferring the data by Bluetooth directly to the software. So this goes in here. So for doing radars, you're generally using a distance meter pointing to where the radar is mounted. If it was cameras on some other vehicles, you can either take off the head and mount this on the wheel and put your distance meter in here, and the distance meter then is pointing to the structure. So that's for systems where the distance to the board or the radar screen is from the wheel center. So we clip this on here or on with this. But in this case, the distance is from the radar itself. So that's just about putting the panel onto the structure, mount the distance meter, bracket insulation, heads. So now we're going to take the heads off the front of the car because we're finished with the alignment. We're putting them onto the structure. We won't lock them up yet because we'll have to level them after. So when we have the two heads mounted, we have our distance meter mounted. So we turn on the distance meter. Sorry, turn that on. Just turn it off again. So when you turn on the distance meter, you have to press and hold it so that it's transmitting, continuously transmitting. In this case, on this particular car, if you don't have when it's beeping, it's transmitting with these badges, and the laser is held to shine through it and it doesn't display correctly. So that's why we just have that bit of tape there for the time being. Yeah. So now we're ready to start. We're ready to start squaring up to the car. I'm just going to move this across here just to get her distance meter. This can slide over and back horizontally on the frame. So now one of the first things we need to do is set the distance. The distance that we're reading here is automatically transmitting from this distance meter. For example, I put my hand in front of it here, shine in there as well. So there's no, in this case, there's no manual measurements that have to be taken. So now what we're going to do is we have a laser up here as well. I'll turn this on and just get the board squared roughly to the car to start with. Just open the boot there. Sometimes, depending on the sunlight you have in your workshop, it can be hard enough to see the laser. You might put a bit of paper or something on it like this so that you can see it. So you can see there, you run the laser through maybe the front badge and the aerial, or the badge on the boot. So to get the structure roughly central with the car. So we need to go that way a little bit. One thing a little bit, and there or thereabouts there, not so bad there. Here then, so for a second. So then for the distance meter, I'm just checking that we're still roughly in the middle of the badge. For the distance meter then, it says the distance is 1175 millimeters. So 1200 is the ideal thing to get at. So once it's gone to green, we're within the tolerance. I'm just going to leave it there and just check, are we still fairly square with everything else. Not too bad. So what we can do now is lock the frame to the ground so that I can't move. And using that upper laser, the green laser, is just to get it in the general area. So we're still fairly close. So now we need to level these bubbles. You tell me when they're getting close to level, so we'll end up these two. No.
Yep.
All right. That's that one, and so that's pretty good. We're still in the middle of the badge. And we're still within our range here at 1206. So now once we have the structure leveled, we can level the heads on here. Level this one. So we're all level. Now it's asking us again that we need to do the ROC because software doesn't know that we've done a pre-alignment check, so we can recall the ROC for this case. You can read through all our information here. So we can recall our ROC. Correctly executed. Go on to the next step. So we just have to wait till it picks up the heads again. So now it's the two heads on the structure are communicating with the heads on the car, and it's showing us here then what we need to do to square it properly with the car. This one is showing that we need to move the structure over to the left, not the complete structure, just the frame here. We can turn here, so it shows their alignment. I'm going the wrong way. If you watch this figure here, and now we're right. So that was, if you shine on that, so that was moving the whole structure over and back. The frame and all was staying to the ground. So now we need another adjustment. Arrows pointing this way. So once we have it positioned correct horizontally, now we need to see these arrows here. One's pointing this way, the other one's going the other way. So this is to move the frame or the structure to get it at the correct angle to the vehicle, so we'll be moving in and out like that. So if you just shine in on this dial here, so I adjust this here, so it just moves the angle of the main beam. So if you go back to the, so it's 0 to minus 0.10 of a degree to plus 0.10. So I'm going the wrong direction there now. Keep going until we get to getting closer. Try to get it close to 0 now. So now we're all green. Just double check that we're still in the middle of the badge. And sorry, I also forgot to mention, if we did need to, it was at the right height when we started, so if you did need to move it up or down, it's an electric motor controlling up and down the height position of the of the structure. In this case, it's just telling us to get it in the centre of the badge. If it was on some other vehicles, it's a different height measurement, so it's another distance sensor here that you turn on, and it measures the distance from here to the ground and automatically transmits it into the software again. So now we can proceed on. Confirm that it's aligned correctly, yes. Final remarks, turn off distance meter. Remove the distance meter. Have the, just turn off the laser, it's turned off already. We have it connected to a battery support unit. Keep the voltage stabilized. The ignition on with the diagnostic interface connected. It was telling us the inclinometer on the front here has to be set to 0 degrees. So in this model Golf, you just set it to 0. On the older ones with the radar down in the front that has physical adjusting screws, it tells you to go to 0, 2 degrees in one direction and then 2 degrees in the other. The older Golfs had actual adjustment screws on it for physical adjustment. This one doesn't have any physical adjustment, it's just all done through the software. So we switch on this and make sure we get it to 0. Pretty close, but yeah, at 0. Structures all lined up. Make sure the key is on. And remember to remove the distance meter, so it's removed. Distance meter with the laser beam flashing. You can't leave it there on the screen for one thing, or the beam would upset the calibration. Turn the key on, connect the diagnostic tester. Next, the dashboard. So now it's at this point and this point only starting to communicate with the car. All up until this point we needn't have even had the diagnostic interface plugged in. Well, we did for the pre-scan, but for the alignment of the board and everything, it didn't have to be connected to the diagnostic tool. So in theory, if you wanted to use your own diagnostics, you'd use the software on here showing you how to align it and square it with the car, and then you could plug in your, if you wanted to use like the whole diagnostic software, if you prefer to use the ODIS on it, you can use the ODIS to do actual this part of it, and use the Technomotor software for everything else. So these are the alignment angles that we have. We can clear the faults here, or we go to calibration, static calibration. Before position the panel as described, press OK. Calibration completed, press OK to continue. Collecting after calibration data, and there's our alignment angles, and now we can go in and generate a report. So it gives us a report, time and date, vehicle details, registration, shows us that we done a vehicle DTC error scanning on the following systems, that we done an alignment pre-check, everything is in green, everything is good, pre-check results good. Then it showed the positioning of the board, of the structure to the car, that we had it at 1202 mil with 0 degrees, horizontal deviation 0.2 of the other one, ECU information, and then the status of the calibration. And then we can print off and sign it. So it's great having everything in one report. You have our diagnostics, alignment and calibration all in one report. So that's about it on calibrating a radar. Hopefully we'll do another video soon on on doing the camera system as well. Okay, thanks for watching.